All right, okay. Good evening, everyone. Okay, so this is Teacher Kamanga in physics. In our today's lesson, we want to revise a question on moments. So this question has been extracted from a paper 1 science GCE 2016 question number 3. All right, so this question is about moments. So we also want to know how are we going to go about the questions that are going to be asked based on moments. So the first question is saying, what is meant by the term moment of a force? What is meant by the term moment of a force? So moment of a force is a turning effect of a force about a certain point or a pivot. I'll go through that one again. We're saying moment of a force, it is the turning effect of a force about a certain point. Okay, this point is the one that we're referring to as the pivot. So our definition will be clear like that: the turning effect of a force about a certain point. Okay, that's what we need to understand. Okay, then we come to the second one, B. So this one we are done. We come to B. We're saying moment of a force about a point depends on two factors. What are they? Moment of a force about a point depends on two factors. What are they? So we understand to say for a body to be at equilibrium, number one, we're looking for number one factor is the center of mass. Okay, center of mass. Okay, the center of mass. So now when we are trying to talk about the center of mass, what we need to understand is that this is a point on an object where all masses seem to concentrate. A point on an object where all masses seem to concentrate. That is the center of mass. Okay. Then the second point, it is the size of the base area. Okay. So the size of the base area also, it is a factor at which moment depends on for a particular object to be at equilibrium or for a particular object to balance. So these are the two of the factors that moment of a force is going to depend on. Okay, so I've talked about the center of mass and the size of the base area. Okay, I hope that one is very clear. Now let's come to this diagram. Now on the diagram we are saying figure 3.1 shows a uniform meter rule which is pivoted at 20 centimeter mark and balanced horizontally by an object of weight 3.15 newtons placed at the 10 centimeter mark. Okay, so this is what we are seeing. So now the question is calculate the weight of the meter rule. Calculate the weight of the meter rule. So now what we need to understand is that for us to know the weight of a meter rule, remember we said we need to locate the center of mass. This is where the weight of a meter rule is going to be, because we are saying this is where all the masses seem to concentrate. So if we're talking about a meter rule, we understand to say it is 100 centimeters. Okay, so the center of this 100 centimeter is going to be at 50 centimeter mark. So where we seem to understand to say the weight of this meter rule, we can find it based on the 50 centimeter mark. Okay, I hope that one is clear, our justification. So now in order to understand this is where we're going to look at the weight that we want to calculate. So in calculating the weight, we understand we're going to use the principles of moments, where we'll calculate the moment of this side is equals to the moment of this side. Then we're going to find the missing answer that we are supposed to calculate. Okay, so now what we also need to understand to say we've been given distance which is in centimeters, of which we understand moment, the distance is supposed to be in meters, so we need to change the centimeters. So before that, we need to look at, we have 10 here and we have 20 here. So we're going to find the difference between 10 and 20. That is the distance from the 3.15 newtons to the pivot. The distance is the difference between 10 centimeters and 20 centimeters. Okay, so 20 minus 10, we have 10. So the 10 centimeters is the one that you're going to consider as our distance between the 3.15 newtons to the pivot. Okay, so we need to change this one to meters. So the only way we're going to change is by dividing with 100. I hope you still remember where the 100 is coming from based on the previous lesson that we had on moments. Okay, so what we're going to have, if we divide by 100, we're going to have 0.1 meters. So the 0.1 meter is the one that we're going to use in our calculation for the moment on this side. Okay, when we come to this other side where we're looking for the weight, this one, okay, so also we're going to look at, we have a 20 centimeter mark there and we have a 50 centimeter mark. So the difference between the two, it is going to be the distance of this weight that we want to calculate to the pivot. So for us to find that one, we're just going to say 50 minus 20, so we have 30. Okay, so 30 centimeters, we should change it into meters, which will give us 0.3. Okay, so this side the distance is going to be 0.3 and this side the distance is going to be 0.1. So those are the distances that we're going to use in our calculations. All right, so let's go to the calculations. Okay, so on our calculations, remember we do not need to forget the formula, which we will mention to say F1 times D1 is equals to F2 times D2. All right, so this F2, it is the weight that we want to calculate, which is on this 50 centimeter mark. So we'll say the F1, it is the force that we have, which is a 3.15 Newton, times the distance 1, it is the 0.1 that we've changed, so we have 0.1. Okay, should be equals to the F2 is the one that we want, that is the force that the weight that we want, times the distance here we've calculated to say it is 0.3. Okay, the 30 that we've changed into the meters. All right, so when we multiply 3.15 newtons times 0.1, we are going to have 0.315 newtons. Okay, is equals to, we have 0.3 F2. Okay, so we divide by 0.3 this side, even this side we divide by 0.3. So this 0.3 and the 0.3 will cancel. We're going to remain with F2 on the other side. So we're going to find the value of the F2 by saying 0.3 into 0.315. Okay, so the answer that we're going to have 1.05. So therefore, in presenting our answer, what we're going to say is, we're going to say F2, which is our weight in this case, is equals to 1.05 newtons. Okay, this was the answer which was supposed to be found as the weight of the plank. Okay, so those steps are very, very important. Remember, we mentioned to say whenever you've been given centimeters, if you're calculating moment, change those into meters so that they are going to fit on your formula. Okay, this has been Teacher Kamanga with you. Thank you.